we had left off yesterday going through picking out what our sample size should be. Because we said the confidence level can tweak how wide our interval is, but the sample size can also help control how wide or narrow our interval is going to be, because the sample size will affect the standard deviation. So if we want to guarantee that the margin of error is going to be within a certain amount, then we can control that by picking a sample size. And so that's the idea of this example. And we can choose what we plug in for p hat. We can choose one of two ways. This is what I talked about at the end of yesterday. Number one, we can, if we have some established estimate of p hat that we think is right, we can use that. So if, let's say we're gathering this data and comparing the trends of 2021 with 2020, 2019, 2018, we take in this survey 5 years in a row, and the proportion is usually 0.3. Well, then let's use 0.3. If we don't know what the proportion is, and you can test this out for yourself, the largest value, because we want to put a maximum cap on the margin of error, the largest value we could get is if we had 0.5 times 0.5 in this standard deviation formula to give us 0.25. Any other value will give me a smaller standard deviation and a smaller margin of error. So the absolute largest I can get would be 0.5. So I can use 0.5 as a stand-in, and then it's not going to go above that. Like, for example, if we had 0.3, then that part of the formula would be 0.3 times 0.7, which would be 0.21. Smaller than the 0.25 and an even smaller margin of error. So the largest possible is the 0.5. So we can either use 0.5 as my stand-in, or we can use an established p hat that we already have an estimate of. All right. Determine the sample size needed to estimate p with a 0.03 with 95% confidence. So I'm going to do this a little bit differently than the notes layout. So I'm going to actually write the formula out here, and then we are going to work through that. So margin of error. We want the margin of error. We want to constrain the margin of error. So we have margin of error equals our z-score times standard deviation formula. P hat times 1 minus p hat all over n. And let's plug in some values. If we want the margin of error to be 0.03, and we want that to be the largest possible value of my margin of error. I don't want the margin of error to be wider than 0.03. So let's start plugging in values. Z-score for a 95% confidence interval, we talked about how to calculate that. You can calculate it, or you can remember when we did it last time, it was 1.96. It's still 1.96. Times the square root of, we don't have a value for p hat. If you don't believe me, it has the example on page 493. It doesn't give an estimate of what p hat might be. So we're going to use 0.5 for p hat. Over n. Solve for n. So some algebra 2 happens. Go do the algebra 2. I'll give you about 2 or 3 minutes. So if we have 1067 point whatever as our sample size, then if we're asking what sample size should we choose, we can't choose a decimal of a person as our sample size. So since n should be greater than or equal to, even though this would usually round down, we're going to go up and choose our sample size of 1068. We want to choose, if I can spell choose correctly, choose n to be 1068, the next largest value. Because again, I want it to be smaller than 0.03, and if I make it 1067, that would create a larger margin of error than I want. Okay. Yeah, I don't like the way the notes show it. I mean, I can show the way the notes show it, but I don't like it the way that they're doing it. All right. And then, so yeah, that's the way the notes show it. And then homework.